Hi and welcome back to the lab. And today here on the bench we have a Yaesu FT-7800, which is this dual band FM radio, and this radio won't fire up. So with the FT-7800, that is a problem what very often happens, and I already have an idea what it might be, and 80% of all these faults are related to a well-known issue. I do not really tell it right from the beginning because I just want to show you how to approach such a problem. So let's go to the bench and let's see if it is exactly what I expect. Okay, and here is our radio, and as you can see it is already connected to our power supply, and what you might already see is that the radio is pulling approximately 3 milliamps, which is quite normal for this radio. So that is, if you like, the standby current which is drawn. So now we're gonna try to fire it up, and let's see what's happened. Well, so what we see is while I'm pushing here the power button, you see that the radio is trying to start up. So you see a rising current, which indicates that the radio tries to fire up, but it can't. So okay, that means that something is still working, but we cannot get it switched on. I don't know if you can hear in the background a little plop sound, so not sure. Let's see if you can hear it. Listen when I press here the button once again. Yeah, so you hear two plop plop, and then it's over, and that as well indicates to the well-known problem. So as I already said, 80% are related to one problem, but there are some other problems, such as that the power supply for our panel here is not given. And before we run into the wrong direction, the first what I really want to check is if our, I believe it is 9 volt, what our front panel is supplied with. So that is the first what we want to check, and then we can go ahead. Okay, and here we have everything prepared for testing, and what you see, and that is the first point of interest, is here this connector to our front panel. So as you might know, we have here of course our main MCU, and there is another MCU or CPU, whatever you want to call it, on the front panel, and this both processors needs to communicate to each other, and therefore first of all we need our power, so our, I believe, 9 volt, but we will double check it on our service manual. And then if this 9 volt are given, then of course there must be a communication between the main board and our front panel, all right? And that is something we can test, and let's see if we can find any signs of communication. Okay, and here we have our scenario. So that is the main board, that is the front panel board, and what you can see is that we have here, not sure if you can read it, so let's enlarge it here a little bit. So what we see here is that we have 9 volt power supply to our front panel. And what you can see as well, that we have here TXD and RXD, which is a data communication between main board and front panel board, right? So now we start and check first if our 9 volt are there, so minimum when we start it up, and then let's see if that is given. If that is given, we directly start and look after our communication line. On this board here we have a nice little test point here on the PCB, and I go down to the test point, and well, so far we can see nothing on our voltmeter. Now let's try to fire it up. Just let me go back to the test point. Now let's try to fire it up and watch our voltmeter. All right, so I hope you have seen the 9 volt. Let's try to start it once again. And I hope you've seen it. Our 9 volt are getting produced and delivered to our front panel. So the next what we need to do is to check if, while we trying to start it up, if we see any communications, okay? And of course I have looked it up in the service manual, so our data communication have to be here on the left hand side, first pin, and then the second one. So one is TX and one is RX. And now let me try to probe these both pins, and let's see if we can see any traffic while we are trying to fire it up. Okay, and again I've prepared it for testing, and down here we should be able to see our data communication while I try to start it up. So let me go down here to the test point, and you see there is something, but that is not what we are looking for. And I try to start it up, and something is definitely happening there, but that is definitely not the real data communication. So minimum one side, transmit or receive side, is not really working. So that was what you have seen there. That was a data communication, but that seems only to be on one side. So the other side doesn't react at all. So that looks to me that we have a communication on one pin. So one side of our main board or front panel board. So of course the CPU tries to start the communication but might get no answer, and therefore the radio cannot start up. And this problem really can be simply mixed up with CPU problem, and sometimes it is, but that is very seldom that we really have a faulty CPU. But it could be mixed up with the CPU problem. Much more often it is something totally simple. So let's see if my idea is right. So let's take off here our front panel, and what we can see here, of course, there is a cable in between, and this cable of course is the connection between the main unit and the front panel unit. And very often this wiring is somewhat defective and is really causing this problem. So let me see if I do have a new cable on stock. Well, and we are quite lucky, so I do have two left, so maybe there, let me open it, maybe there is a minimum one which we can use. So you see that is the bridge wire, and what we do of course is to connect it here to the radio, and yeah, let me put it here in. Now we have of course done our connection so far, and now yeah, I have to connect the power supply. Okay, so power supply is connected to the radio, and now let's see if we can get here any live. Hey, here we are back working. So you see, that is exactly what I've expected, and that really happens very, very often. Okay, and now let's test once again our data traffic, if it is now present, and if it looks like how it should. So let me go to the first pin, and wonderful, have a look. So you nicely see the traffic, so that is one line, okay, and what you see is definitely the traffic and the packages, the data packages, which are here on the line. So that is a permanent data communication between our processor. Let me go to the second pin, which is here, and yeah, so again, so on both pins, transmit and receive side is working just fine. So you see everything is absolutely fine, and what you can see as well, so it is a voltage level of about 5 volt, but it is not a DC, it is a kind of AC, of course, so that is a digital data communication. So therefore it is proved that this was our problem. And of course we need to do a short transceiver test. I'm doing not an entire testing, but just to be sure that the radio is receiving, and that it all looks fine. So that is what we definitely have to do, and I've already connected my tester, but there is another thing we have to do. So here our microphone connector needs to get replaced, so that is what we want to do. So first, of course, I try to really only put here a new so-called Western connector to the radio, but sometimes it is not possible. So if that is not possible, we definitely have to swap out here the wires, the whole cable. But first, of course, let me try to get a new one onto here. But now let's have a look to our radio, how it is performing. Okay, and here you can already see our test figures on 2 meter. So I'm really feeding in a very low signal, which is very close to the noise floor, and you see it is still performing with a very good SINET, so that shows very good, so nothing to complain. And let me here increase a little bit the signal, let's say up to an S9 level, which is minus 93, and look here, crisp and clear sine, and we are approximately at 40 dB SINAT, which is definitely a very clean signal. So I believe that our receiver in the radio is working absolutely perfect, nothing to complain. So next step will be to swap out our connector from the microphone, and then we can definitely check. No, what we do first, let me connect the microphone to the radio first with the old connector to see how it is working. Let's see. And that is okay. That is not working directly. So yeah, let me connect a stronger power supply, because my power supply is not supplying enough current for transmit. Okay, once again, so the connector from the microphone is connected to the radio, and now let's see, press PTT, and 46 watt output power, frequency is quite nice. Obviously we have modulation, so that is fine. So that means that the transmitter works, the microphone works. So let's go ahead and let me simply swap out the defective connector next. And if you ever have asked yourself how the crimp process is working out, so the new Western connector is here in the tool, and as you see, the cable is attached already to it, and now we can finally really crimp it. So it is working like so, and now the only thing is to take it out, and if I have not mixed up wires, then it will be done. And here again a close-up of the new connector, and you see how nicely it is now fitting in here. So now we can test if it is finally working. And let's see if it fits in here. And you see how nicely it is working. So that is just nice. Okay, and let that call final test. So you hear already the receiver. Let me turn down the annoying tone in the background, and let's see what we have. So you see, yeah, the backlight illumination is working. So that is already definitely a good sign. So no short or something, which well, always could happen. And now let's see if it will go into transmit, and you see it is going into transmit, but let me see if we have modulation, and if that is given, then yeah, we are finally at the end. Okay, and as we see again, our receiver with an S9 level right now, and here is our microphone. Let's push to talk, and you see it is switching over in transmit, and 1 2 1 2. So we see it is modulating, and that means definitely our radio is working, and the new connection to our microphone is also working. And here, for all of you who still do not believe that it was our wiring here, have a look. So that is connected to my tester, and now we really can go through to all of our 6 wires which we have here in our configuration. And now you see we have the first wire, both are lightning, that means connection is given. And let's go through second, third, and have a look. So our 4th wire is disconnected or interrupted. This is the 5th, which is fine. The 6th, now we move on the manual through until we come up to the 1st, and once again we can go through, and you see our 4th wire inside our cable is disconnected, interrupted, or whatever you want to call it. And that is a proof that our wire here, which we have indicated as faulty, is really faulty. That is finally the proof. And finally, that is the end of our video, and the radio can go back to its owner. Thanks for watching, and catch you next time. Bye.